Hello everyone, I am Pavithra Devi working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science in DrSNS College of Arts and Science. I am going to take the class about data science workflow modeling and evaluation. In the data science workflow, modeling and evaluation are crucial steps where the data is used to create predictive model and assess their performance. The phase help to uncover pattern to make prediction and evaluate the effectiveness of the chosen approaches. Next one, modeling. They having lot of key activities. First one is selective model. In this step, appropriate machine learning model or statistical techniques are applied in the pre-processed data to uncover pattern to make prediction or device insight. The first key activities is the selecting model. Choose the appropriate model based on the problem type, classification, regression or clustering, etc. and the nature of the data. Next one, common type of models. Supervisor learning model that learn from the learned data to make predictions, and a classification for the categorical outcome, example logistic regression, decision tree, random forest to support vector machines. Regression for the continuous outcome, example linear regression, ridge regression, neural network. Next one, unsupervised learning model that identify the pattern in unlabeled data. Clustering group of similar points, example K-means hierarchical clustering. Dimensionally reduction Dimensely reduction reduce the number of features while maintaining essential pattern, example PCA. Next one, reinforcement learning model that learn through interaction and with an environment, aiming to maximum rewards. Q learning, deep reinforcement learning. Next one, splitting the data. Next key activities is splitting the dataset into training and testing set to evaluate how well model generalized to unseen data. Training set used to train the model. Testing set used to evaluate the model performance. A common split 80 by 20, 80% of training, 20% of testing, or 70 by 30 depending on the data set size. Next one, training model. Third key activities. Feed the training data into model. Allow it to learn patterns, relationship or structure in the data. The process may involve adjusting the model parameters, hyperparameter to optimizing the performance. Next one, hyperparameter tuning. After initiating training, fine-tune the parameter set before training beginning of the model. Improve the performance. This can be done through the techniques like credit search, random search, Bayesian optimization. Next one, cross validation. Cross validation is the help access to the model performance more robustly by training model on the different subset of the data, testing it on the others. The minimize the risk overfit to the specific training sets. Next one, evaluation. Once the method is trained, it's time to access how well it performs on the unseen data. This where the model effectiveness is validated and metrics are calculated to determine its success to solving the problems. The key activities, model evaluation metric. The evaluation metric depending on the type of model, specific problem you are solving. Common metrics include classification metrics for categorized outcome. Accuracy, the propagation of the correctly predicate instance out of all the instances. Precision, the proportion of positive prediction out of overall the predictive positive, importance of minimum false positiveness. Recall sensitivity, the proportion of true positive prediction out of all the actual positives. Phi score, the homogeneous mean of precision or recall the balancing the both metrics. ROC curve and AUC area under the curve evaluate the performance across the different classification thresholds. Regressive metrics for the unconscious outcome. So uncontinuous outcome, mean of absolute error, average absolute difference between the predicate and actual values. Mean squared error MSME, the average is the square difference between giving the more weight to the larger error. R squared measures how well the model explains the variance of the data. And R required the squared in indicate the perfect fit while 0 indicate no explanatory bubble. Model performance and evaluation. Evaluate the model on the test data to see how will the generalize the beyond training data. Next one, overfitting versus underfitting. Overfitting occurs when the model learns the noise in the training data, leading to poor performance on the unseen data. Data is high variance. Underfitting occurs when the model is too simple and fails to capture and underlining the pattern in the data. High biases, striking the right balance between overfitting and underfitting. Next one, model comparison. In the model habit, try compare their performance using the evaluation metric to determine which the model perform the best of the set. Next one, model interpretability. For the sum of the model, especially back box model like neural network, is important to interpret, explain the result. This technique is examples the lime or practical or shape values. Thank you.